Gentlemen, hello and welcome to Mr. Smith's office. What we're going to talk about today is pretty much a standard set of micrometers. This is a Mitutoyo 0 to 1 inch micrometer, capable of measuring 0, obviously, to 1 inch, just a tad more. And the way that micrometers work is every rotation of the thimble provide you with a 25 thousandths closure or opening of the faces right here. So when we talk about this, and what I'm going to do is I'm going to crank this closed to exactly 100 thousandths of an inch, which is right there. You can see that as you come up on the barrel, that the 0, the center line, and everything all line up, making that opening you see over here exactly 100 thousandths. So what we need to think about is that every time we rotate the barrel, or the thimble rather, one revolution, we move the faces out exactly 25 thousandths. Keeps the math pretty easy, so we'll see that we've started at 100 thousandths. One rotation out is at 25 with a 0. This is exactly 1/8 of an inch. Well, since designers don't generally make it that easy, what we need to do is add just a little bit of math to this and say, what happens if we measure an object and instead of coming up on the 0, it comes up on the 17? Well, that's inconvenient, isn't it? So if we do the count, we see that we've got 1 plus 25 plus 17. So 25 and 17 is 42. Okay, and with a little added fun of this is that these mics are equipped with a 10 thousandths per inch vernier. Okay, which is what you see on the top here. We'll go into that a little bit more in detail. So wherever we would stop these mics, we would literally say, okay, so 213 thousandths, 0.213. And if we open them up to the next 0, we'll see that what we've done is line them up on the 0.225. And again, as the object you're measuring gets bigger, these open up to, well, whatever they might open up to. This, as I say, designers don't always make it convenient to measure something, and generally remember that the design specifications and the blueprint are our Bible. We make things to the blueprint. So by way of example, what I'm going to do is I happen to have in my possession, as you can see behind the micrometers, a 1-inch dowel. Now, for most general purposes, this is a very large dowel. Seen mostly with very large tooling. It may be used for an alignment pin, or interestingly enough, it works very well on the TL1 to set your X diameter. And we all know what +1 is. So what I'm going to do is I'm going to crank these up to the point where I can just feel the faces making contact. Once again, I would note that I run my micrometers a little bit more loose than some folks. Some folks like them a little tighter. So the point is that you need to develop your own feel with a set of micrometers. You can see that dowel rolling between those faces. It's a nice fit. And once again, that's rather difficult to teach because you have to develop that with experience. So we think we've got a good read. I lock the micrometers. And so if we look at that and we say, oh, what does that read? That reads 1.000 something. Okay? So let's now is when the vernier comes into play, because what we're going to do is we're going to look and see which of these lines on top lines up the best. We look at the 0 and we see, well, we're not quite on the 0 and we're not quite on the 1, but we are pretty much exactly on the 2, off the 3, off the 4. You'll see that as the graduations go around, they get farther and farther off. So the actual measurement of that dowel pin, the actual diameter, is 1.0002. And once again, you will have to develop your own feel for micrometers. That's pretty much it. The only other side note is that micrometers work on a 40 thousandths pitch, which will provide us with a 25 thousandths per revolution advance or retract on the faces. And gentlemen, a reminder, these are precision threads. Unless you really do understand what you're doing, my advice is don't take them apart. But that's pretty much it from Mr. Smith's office today. I would certainly hope to see you in the Lincoln Tech Lab very soon.